Quality management. Quality was very, very important, and still is important though, but was a major, major issue in the 80s and 90s. And it was a major issue because many Japanese companies began to outcompete North American companies on the basis of quality. One of the most noted companies from Japan at the time was Toyota. And so a lot of companies wanted to follow Toyota's quality strategy, its lead. And so many of them went to study the Toyota production system and so forth. So while quality was a major source of competitive advantage in the 80s and 90s, since then it has sort of died down. However, it is still very important for all organizations. I mean, you simply can't come to the market and sell a product or a service if that product or service does not meet certain quality requirements. And so we can say that quality has moved from being an order winner to now an order qualifier. All right? And so operations managers still have to understand service, and not service, but quality, and what that means in terms of meeting customer expectations around quality, or maybe even in some markets that quality might still provide some source of competitive advantage. So what you want to do is to, from an operations standpoint, is to build that sort of total quality management system that would allow the products and or services to meet customer expectations. And that's really the heart of it. And so to be able to do that, we have to understand what quality means for products, what that means for services, and what it means for strategy. So quality and strategy have some relationship. So we see here that through managing quality and ensuring that you produce quality of an international standard can actually support either a strategy based on differentiation, on cost, or response. So all of those can be supported by having an effective quality strategy. In a lot of cases, it could help the firm to actually increase its sales, although to a lesser extent nowadays because quality is now a requirement. But at the time when it was a source of competitive advantage, it had that potential to actually drive sales because it was an order winner. But it can continue to reduce cost associated with production. Building the sort of a quality organization can be challenging, but it's necessary. And so operations managers must play a key role in enabling quality within any organization. Quality can improve profitability either by sales growth or by reducing costs, according to this diagram right here. So what is quality? How do we define that? And we have a variety of definitions: meeting customer expectations, conforming to specs, and so on. But then it's useful to have some different definitions because they have implications for how you manage the OM system. So one possible definition given by the American Society for Quality is that is the totality of features and characteristics of a product or service that bears its ability to satisfy stated or implied needs of customers. So that's one of the ways to define it. So you must understand product features or product characteristics and the relationship of those two things to customer expectations. If we understand that, then we're well on our way into designing an OM system that can support quality. Now, there are different ways to view quality, and here are some different definitions. One is called a user base. So basically, the user decides what is of importance or value to them and as long as it meets their expectations, they're fine with it. In a case, there's another one called a manufacturing based definition, which is usually we specify some manufacturing requirements, and the ability to conform to that is seen as a form of quality. So conformance to specs. A product based definition is that there is some attribute, some measurable attribute in the product. So like the octane level in gasoline, for example, can be viewed as that variable, and the higher the octane level, the higher the quality. Or in some cases, it might be butterfat in cream, and the more butterfat that you have, the better the quality is perceived to be. All right. So we know that quality can drive reputation. It have implications for product liability issues. If you produce poor quality product, then chances are something will go wrong in the field, and you may end up paying for that. It has global implications because your ability to compete internationally will depend on the extent to which you can meet global expectations around quality. Now, quality, while we have a single definition, is a multi-dimensional concept. And it's important to understand those dimensions because in most cases, it is very difficult to design a product to excel on all the possible dimensions of quality. So here are some. We have David Garvin wrote an article called The 8 Dimensions of Quality. So we have performance quality, features, reliability, conformance, durability, serviceability, aesthetics, perceived quality, and value. And so performance quality talks about some primary characteristics. So if we think of a computer, for example, the speed of that computer in terms of gigahertz, 2.8 gigahertz, 3.2 gigahertz, and so on. Features, all the bells and whistles that a product has. Reliability deals with the probability of the product performing its function when it's expected to do so. So a highly reliable product will do what it's supposed to do. Conformance, basically meeting the specs. Durability, how long does the product last? Serviceability, how easy it is to actually service that product. Aesthetics, the look of that product. The perceived quality is what people attach to a product in terms of its value. And that usually comes from marketing and branding, like a Nike sneaker versus a Reebok sneaker. You might perceive Nike to be of higher value, largely because Nike may have done a better job of marketing its products. And then value, how people perceive value in a product. And the consumer will actually determine that in a case like that. To sort of encourage companies to pursue quality, when the Japanese were actually giving the American companies a very hard time, a tough time, the Americans established what they call a Malcolm Baldrige Award for quality. And so in 1988, the government named this after, I believe it was, the Secretary of Commerce at the time, Malcolm Baldrige. And the American Society for Quality developed a set of criteria, and companies actually would submit applications for that award and would have to be assessed and evaluated against the criteria, and awards were made. So you see a number of companies here, such as Honeywell, Federal, Midway USA, Corning, etc. And I'm sure if you were to look, you'll see that GE, companies like GE, Motorola, they all have won the Malcolm Baldrige Award. At that time, it gave these companies a marketing edge because they could claim to be a Baldrige Award winner. It's kind of like the Grammys, if you wish, of quality. So saying I'm a Grammy Award winner opens doors. Well, same thing with Malcolm Baldrige. Now, the Malcolm Baldrige Award was actually awarded on several criteria. In 7 or more, I think, this is more than 7 here. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 domains. And there's a total of 1,000 points. And the points are allocated as follows. So we see leadership, strategic planning, customer market focus, measurement analysis, and knowledge management, workforce focus, process management, and results. So these areas, a company that is actually excelling at quality will do very well in all of these areas. And so companies were encouraged to use the framework as a way of driving quality in their organizations. One of the reasons why we need to pay attention to quality is because quality has costs associated with it. If we produce good quality products the first time, we could really reduce costs. We want to think of scrap rates, scrap that comes from perhaps defects in a product when it was manufactured, then that is waste. So we typically think of 4 types of costs associated with quality. The prevention costs, so all the things that you do to make sure that you don't make mistakes. The appraisal costs, assessing your processes, your parts, and so on. That includes some inspection to make sure that the products are not defective. Internal failures, if the product fails internally, if there's a problem before it gets out, then what's the cost of doing this? So perhaps you discover that there's a crack in the product, a chip. It was not manufactured properly. That's fine. And so you may have to rework that. The external costs is what happens if you discover the mistake in service. So in some cases, it may have catastrophic effects. You might actually hurt someone, and the cost of liability can be very, very high. And so the idea is that if you were to look at various cost functions, right, that it is possible to find some point where you have the sort of the best level of investment in prevention and appraisal versus the internal and external failure costs. So it's possible to do that. When quality was in its heyday, there were a number of folks actually sort of advocating for companies to adopt certain quality practices. And here are some of the folks that became very popular. We call them gurus. Edwards Deming, who was largely a statistician and really helped with statistical quality control. Juran understood that top management basically had a major role to play, and that if you communicated to them in a language of money, that they would actually be committed to pursuing quality. His concept of quality was fitness for use. Feigenbaum helped to develop total quality control, and Phil Crosby's idea was that companies should always pursue 0 defects as a goal, because quality is free. In the end, you save money always. And that was his philosophy. We won't get too deep into the philosophies. I think you could read that for yourselves. But there's some ethical dimensions to quality, in that quality, when you pursue it, will help you to produce safe products. Products that are considered of good quality, that meets international standards and so on. However, if you produce poor quality product and you don't pay attention to it, then you have some risk of potential injuries, lawsuits, recall, and then it might actually drive the governments to actually increase the amount of regulation. So it's important to recognize that quality is connected to ethics. Now, you may have heard of ISO 9000, ISO 14000. One of the things that was done back in Europe was to kind of develop a set of what we call quality standards. And the purpose of that was to allow companies to be able to sort of trade with each other. If I was selecting a company that was ISO 9000 certified, that meant that it met a set of quality standards and practices, then I knew what I was getting. I could expect good quality. And so companies use ISO 9000 as a way of differentiating themselves, and they were very proud to display the ISO 9000 certification. So there was these common quality standards for products across Europe and Canada and America, basically North America and Europe, and that companies attempted to adhere to it. So there would be an accrediting body that would actually come and conduct the inspection and the audits or whatnot, and then certify a company as being ISO 9000 certified. When environmental regulations became important, then a number of companies started to pursue ISO 14000. So a set of standards were developed for being environmentally responsible, and if your company or your organization conform to those standards, it can become ISO 14000 certified. And that means that your company is practicing in accordance with a set of standards around environmental sustainability. Now, if you look at the history of quality, you'll find a number of different types of efforts: total quality control, quality assurance, and so forth. But then what was discovered is that the Japanese were using what we call TQM, total quality management, a sort of a much more holistic approach to quality. And so TQM really is about encompassing an entire organization, all its people, all its processes, all its systems. And it stresses the importance that management has to have a philosophy of continuous improvement. In other words, never resting on your laurels and always searching for better ways to do things, ways to improve your products and services. So total quality management, as the term suggests, is really a holistic approach that would look at your complete systems, would look at the organization from end to end, and engage all employees in attempting to improve quality of products and services. All right. Each of those gurus that we talked about earlier had, as part of their philosophy, had a number of points that you would consider. And so Deming had his 14 points. We have people like Phil Crosby had his points as well. Juran had his philosophy as well. So all of that was basically just frameworks to allow companies to pursue quality in a very systematic way. There are 7 concepts of TQM that companies can use to pursue the philosophy. One is the idea of continuous improvement, that you never rest on your laurels. 2, Six Sigma, which is a specific program that attempts to look at the sources of variation in processes and try to achieve a target of Six Sigma quality, which basically means that you're producing at a defect rate of 3.4 parts per million. If you produce 1 million items, then you should not see any more than 3.4 parts that are defective in that. So that's a major standard, and that requires a fair amount of work. Employee empowerment, which is basically giving employees the power to shut down processes if the process is producing bad quality. Benchmarking as a way of looking at what other best practice firms are doing, and then your organization actually attempting to copy what these firms are doing as a way of improving its performance. Just-in-time systems, which focuses on trying to minimize waste and trying to minimize inventory, because inventory is seen as waste. Taguchi concepts basically is what we call a loss function, which shows that as you create more and more defectives, the loss to the organization increases exponentially. And so in designing, you could accept a certain degree of failure, but beyond a certain point, that design is unacceptable because of the exponential rate at which the cost of failure would actually grow. And then of course, you got to know some tools that you can use to assist in improving quality. All right. So we'll skip through some of those slides because they basically just expand on each of these areas, which we could find in our textbook. Deming came up with this cycle, or actually it's called a Shewhart cycle, popularized by Deming, where it's a continuous improvement cycle which says you plan, then you test the plan, you make sure that things are working, and then you implement the plan. So, but the plan comes from essentially identifying problems and issues, making recommendations for improvement, and then that becomes your action plan. And then you go through this cycle of continuous improvement. So it's just a basic tool. Six Sigma, as I mentioned before, 3.4 defects per million. And so you want to reduce defects and lower costs, improve customer satisfaction, all at the same time. There are certain aspects or elements to Six Sigma quality. You could see here that we want to be able to have the product specs representing 6 standard deviations of our process. All right. There's a sort of very structured approach towards achieving Six Sigma quality, and we refer to that as the DMAIC approach. And it stands for the following. D would be define the critical outputs and identify gaps for improvement. So of course you'd have to collect some data, look at some of the outputs from the processes and see where you're not performing well. Measure the work and collect process data. Analyze it, improve the process by understanding what's driving the gaps in your performance, and then you establish some control mechanisms so that you make sure that you maintain the gains. So that's basically a standard process for process improvement or quality improvement. But the idea is that you want to achieve such a level of performance that you are only producing 3.4 defects in every million products produced. All right. We have employee empowerment, which I talked about earlier. Quality circles, a group of people coming together to solve quality problems. Benchmarking, where you look at what other companies are doing. And so the different types of benchmarking, competitive benchmarking, benchmarking companies that are not necessarily not competing with them, but they become kind of like role models for you. All right. So decide what you're benchmarking, get a team together, make some observations with your partners, collect the data, analyze it, and take some action to improve your own performance in that regard. Okay. On the service side, or even product side, what are some best practices for resolving customer complaints, if we actually do have those? A couple of things to think about is that we want to make it easy for customers to complain. If you make it easy for them to complain, then you have a source of data that can be used for continuous improvement. Some companies shy away from customer complaints. They figure the customers are too picky and make them feel bad. But actually, it's a great source of information. It's free market research. Respond quickly to the complaints because then it helps to improve loyalty. Resolve complaints on first contact. It reduces long-term costs or long-run costs. Use computers to manage complaints because then you could discover trends, you could analyze them, and so forth. And then recruit the best recruit people for the jobs. You need to match individuals to the jobs. Okay, so recruit the best for the customer service jobs. Don't just treat it like we need somebody there, so let's find the cheapest person that we can, but find literally the best person. What are some tools that you could use in total quality management? There's some very interesting tools. We could talk about tools that allow us to generate ideas or to get a sense of certain groups of prevalence or presence, of problems and issues. Scattergrams, check sheets, cause and effect diagrams, and you'll see what those look like. Pareto charts and flow charts. And then we have histograms, some statistical tools that allow us to sort of analyze data that we collect. All right. So let's see what some of those tools look like. A check sheet is basically a way of just organizing data. If you have these defects and you're looking at on an hourly basis, which of these defects are actually occurring? So we see in the first hour 3 of A, 2 of B, 1 of C, and so forth. So at the end of the day, you could develop a tally for each of these defects and get a sense of where most of the defects actually lie. You could take that information and then actually plot it to give you a bar graph of the occurrence or frequency of each of those defects in an 8-hour period. A scattergram allows us to look at perhaps two variables and just kind of look at an XY scatter, which is how are they connected. And in some cases we may see a trend. In this case there's a negative trend. The higher the absenteeism, the lower the productivity, and that seems to make sense, right? The cause and effect diagram, which is one that I like a lot, basically say if we have an issue, then we could try to identify potential causes, and we could group the causes into materials, our methods and policies, our manpower, and our machinery. So let's say one of our defects is that we have late deliveries of packages because we are somehow a courier company. Then we could look at our methods, we could look at the materials that we use, we could look at the manpower, the machinery and equipment that we use, the technology and so forth. So it allows us to systematically really try to analyze what's wrong with our quality. Pareto chart basically takes the frequency data and create a bar graph, but it's an ordered bar graph, which means that we go from the highest to the lowest. And it tells us the 80-20 rule, which is the 20% of the problems, or the cases, or the causes, that are driving 80% of the problems, the 80-20 rule. Flowcharts allow us to actually look at a process and assess what's taking place at each stage, and then potentially find ways of strengthening performance at each of those stages. We know from statistics we could use histograms to analyze data to see what the distribution actually looks like, and that can be quite helpful. Quality control charts basically allows us to set limits within which we expect a parameter from a process to vary, and then whenever we fall outside of those limits we consider those outliers, and those outliers are examples of defects. So if we have a normal range within which we expect that variable to exist, if it jumps outside of that, we say that there's something that is driving this behavior. So there's an assignable cause. So when values occur outside of the range, there's a problem. Within the range is okay. All right? But the likelihood of being outside that range should be rather small. So it's kind of like applying hypothesis testing. If everything is in control, the values should be in that range. If it's not, the process is not in control, then the values will fall outside of the range. And the reason why we'll conclude that the process is not in control is because the probability of existing outside of the range, and these happen to be 3 standard deviations, which means that 99.97% of all of our values should be in that range. So why did these occur on the outside? There must be something going wrong with our process. All right? And we just see a couple of examples of missed free flow. So we've seen a cause and effect diagram being demonstrated. They could be in the material, the ball, the method, the shooting process, the machinery or the hoop and backboard, and then the manpower, the shooter, person actually shooting. And we see just different types of potential problems that could exist. Lopsidedness of the ball, the pressure, or the hand position, the knees and the balance with the method, or the backboard stability or the rim height with the machine, or the conditioning and training and consistency of the shooter. So all of those things are examples. Just an example of a Pareto chart. And we see an example of a flow chart with for an MRI, with the physician, all the way down to the patient, discussion with the patient, down at step 11. All right? Right here we see. And statistical process control, as I mentioned, essentially what we're looking at is whether or not the values that we observe from the process are within the 3 standard deviation range that we created, or if it's outside of that. If it's outside of that, then basically it's an outlier. All right. And so here we have a problem with this case right here. Inspection is really part of a process of just ensuring that the products and or services that you're delivering meet the expectations. And so one of the things we want to keep in mind is understanding how to inspect, who should inspect, when to inspect, where to inspect. All those things are important. So we could consider inspecting at the plant where the supplier is producing, or at your facility when the product actually is received, or before costly or irreversible processes during a step-by-step production process. So you would inspect each stage of the process when the production or service is complete. And that used to be the traditional way after production. But the danger of that is if there's a problem, it's hard to fix it at that point, before delivery to your customer and at a point of customer contact. So these are all places where you can inspect. And we have to be mindful that we make inspection efficient, because you could have worker fatigue, measurement error, process variability. And remember that you cannot inspect quality into a product. You have to design the whole product production process so that quality happens naturally. Also design the product itself so it makes it rather easy to meet the quality requirements associated with that product. All right. If we think about service industries, how do we inspect in those kinds of organizations? Well, here's an example of a law office. You might inspect at the receptionist. Is he or she answering the phone by the second ring? We could look at billing, the accuracy of the billing. We could look at the attorney, the promptness of that attorney in returning calls, or even the quality of service that they actually provide. Okay. Hard Rock Cafe, which is Hard Rock Hotel. We could do inspection at the reception desk, the doorman, the room, the minibar, and these are some standards. Whether not at reception desk, you use the customer's name, you greet in less than 30 seconds, all lights working, spotless bathrooms, and then restocked and charges are accurately posted to the customer's bill. All right. So these are just more examples here. At a hospital, billing, pharmacy, lab, nurses and admissions, and all more examples. If a restaurant, the busboy, waiter, we could talk about a chef, etc., etc. In the case of a Nordstrom department store, display areas, stockrooms, sales clerks, etc. Briefly, let's look at in services. It's a little more difficult to manage quality, largely because of the intangibility of services. And so we need to focus on ensuring that customers actually evaluate, and first of all, we must make sure we know customer requirements, and that quality when it comes to services is typically in the eye of the beholder. Fitness for use. This is where Joanne's definition makes a lot of sense. And the customer is the one that will dictate to what extent they feel satisfied with your services. Just a couple, I want to get into some dimensions of service quality to wrap this presentation up. But we must recognize a couple of things, that the tangible component of services is also important. So there could be some parts that are intangible, just the environment and so on, but in the actual service there may be some tangible parts that have to do with actual customer contact. The service process is also important, and service is judged against the customer's expectations, fitness for use. And of course, there will be some exceptions to the service delivery that will happen. All right. Here's UPS actually is making some specs for their service, which involves the individual as well as the packages and so on, how they handle. And we could see, the hair, sideburns, no smoking, undershirts must either be white or brown. So they got a whole lot of specs for their employees. Last but not least, let's just wrap it up with this final slide. The same way we had dimensions of product quality, we now also have dimensions of service quality. And some of them are similar, but also we see some that are a little different. A reliability of the service, consistency of performance and dependability, responsiveness, how fast you get service, competence, whether or not the customer service agent is actually knowledgeable and helpful and they understand the product or service that they're delivering. Do they have the skills to deliver it? Access, how easy is it to actually get access to be able to participate in that service? Courtesy, the treatment that you get from your customer service representative. Communication, when the customers are well informed. Credibility, do you trust or do you believe this particular organization? Security, is your information safe? Are you safe when you're actually from risk and other forms of danger when you're doing business with this organization? Does the business actually understand your needs? And the tangibles, such as physical evidence, the stationery, the decor, the chairs, the tables, those things are some of the tangible aspects of the service, and they must meet certain requirements. So we will stop here, where we will see that quality continues to be important, and even though quality is no longer, in a lot of cases, an order winner, it is still an order qualifier, and as such, companies that are wishing to compete with serious competitors often need to meet the quality requirements and then find some other source of competitive advantage. So operations managers must ensure that the OM system, either through its processes, its supplier relationships, HR, its location and accessibility, layout, all these areas, product design, service design, all of these areas impinge or impact on the quality of products and services that an organization produces.